All right, here we go. We're going to look at another question. This is looking a little blurry to me, and I don't like that. But fortunately, you should have a hard copy of the problem in front of you, so you can work off of that. So this is question number 5 from the 2018 AB exam. Again, the exam you would have taken if you were in calculus in May of 2018. And in part A, let's see, we're told that f is going to be the function e to the x cosine of x, so that means e to the x times cosine of x. And I want to find the average rate of change of f on the interval 0 to pi. Average rate of change, don't overthink it, that just means slope. Slope in the way you would have found slope in Algebra 1. So if you want the average rate of change, or AROC, on the interval 0 to pi, we're going to evaluate f of pi minus f of 0 over pi minus 0. Well, what is f? F is e to the x times cosine of x. So e to the pi cosine of pi, that's f of pi, minus f of 0 is e to the 0 times cosine of 0 divided by pi minus 0. And before you start to panic and you're like, oh my god, what am I going to do? If everything is a number, you get to stop. So e is a number, pi is a number, e to the pi, it's some number. Cosine of pi, I do expect that you know that from trigonometry, from your pre-calculus course, that that's -1. E to the 0 is 1, cosine of 0 is 1, but none of that matters. If everything is a number, you get to stop. This is a safe stop right here. For those of you that want to go further, all that you're doing now is risking the point you just earned. It's going to be e to the pi, cosine of pi is -1, minus e to the 0 is 1, cosine of 0 is 1, divided by pi, or negative e to the pi minus 1 over pi. That's the best answer. That's the most simplified, most compact answer, but it's no better in terms of the College Board than this answer up here. So stop here. Don't waste your time. All right, part B. Part B, what is the slope of the line tangent to the graph of f at x equals 3 pi over 2? Now we get to do some calculus. Slope of the line tangent to the graph of f, that means f prime. And specifically, I want f prime evaluated at 3 pi over 2. F of x, we know, is e to the x times cosine of x. To find f prime of 3 pi over 2, I first of all find f prime of x. How am I going to do that? E to the x times cosine of x. Product rule. Product rule says take the derivative of the first, which is e to the x, leave the second alone, plus leave the first alone, times the derivative of the second. That's your derivative using the product rule. Now you need to evaluate your derivative at 3 pi over 2. So this is e to the 3 pi over 2 cosine 3 pi over 2 plus e to 3 pi over 2 times negative sine of 3 pi over 2. And we've talked about it before. You know what I'm going to tell you to do. If everything is a number, stop. If you do decide to go further, it better be perfect. Cosine of 3 pi over 2 is 0. The sine of 3 pi over 2 is -1. So we've got 0 plus e to the 3 pi over 2 times the negative of -1. So that's e to the 3 pi over 2. This one is worth 2 points. First, for coming up with your derivative using the product rule, and second, for the evaluation, which is right over here before you started any simplifying. Part A was worth 1 little point. Part B, 2 points. I would expect lots of students to be picking up the full points for Part A and Part B. Part C and D are going to be a little trickier, a little more action-packed, but I think we're going to be okay. In Part C, find the absolute minimum value of f on the interval 0 to 2 pi. I want the absolute minimum value of f. That means the lowest point. So I don't necessarily know what the graph looks like, but let's say that my graph looks something like that. If this is the interval 0 to 2 pi, the absolute minimum occurs either where you have a relative minimum, so like this point over here, let's call it A, or it occurs at your endpoints 0 and 2 pi. And depending on the graph, depending on my endpoints, this point over here on the far right at 2 pi might actually be lower than the value of the function at the local minimum. So ultimately, I need to determine, does my graph have any relative minima, where the graph changes from decreasing to increasing, and I'm going to evaluate the function at the local minimum, and I'm going to evaluate the function at the endpoints, and whichever one gives me the smallest value is the winner. Now that sounds easy, but that's going to take a little bit of work here. So here we go. We've got f of x equals e to the x times cosine of x. To go after a minimum value, I need to take my derivative, which we already evaluated earlier, or found earlier, e to the x times cosine of x, plus e to the x times negative sine of x, and I'm going to set that equal to 0, because that's where I am going to possibly have a local minimum. Now look at this equation. I've got to solve this equation that has the exponential and trig ratios on the interval 0 to 2 pi. This is where I think a lot of students are going to get stuck. So let's proceed carefully here. E to the x times cosine of x plus e to the x times negative sine of x. I see that I've got a common factor of e to the x, and so I'm going to factor that out. If I factor out the e to the x, I'm left with cosine of x plus negative sine of x, so minus sine of x equals 0. I have a product, e to the x times cosine of x minus sine of x equals 0. That means e to the x equals 0, or cosine of x minus sine of x equals 0. E to any power will never be equal to 0. So this guy over here is not possible. Does not contribute a solution. Where is cosine of x minus sine of x equal to 0? I think this is going to be a little tricky. So how about if I rewrite this as, where is cosine of x equal to sine of x? Now I don't want to spend the whole video going over the trigonometry here, but on the unit circle, the cosine of x represents for any angle. The cosine of x, or theta, represents the horizontal length, and the sine represents the vertical length. In quadrant number 1, the cosine and the sine have the same length if this central angle is 45 degrees or pi over 4. There's one more place where the cosine and the sine have the same length, and that's down here in quadrant number 3, where now they're both negative values. I need the side lengths to be the same, but they're negative values. This central angle is also pi over 4, or 45 degrees, but the big angle, when I measure from 0, is going to be 5 pi over 4, or 225 degrees. Pi over 4 and 5 pi over 4 are my candidates for a local minimum, or candidates for an absolute minimum. What I'm going to do now is I'm going to evaluate the original function, f of x, at my candidates and at my endpoints. So what do I mean? Mrs. Blakely at East End loves to make a table of values. Her students are so good at this. So here's my x value. Here's f of x. I'm evaluating at 0 and 2 pi because those are endpoints, at pi over 4, and at 5 pi over 4. F of 0 is e to the 0 times the cosine of 0. F of 2 pi is e to the 2 pi times the cosine of 2 pi. F of pi over 4 is e to the pi over 4 times cosine of pi over 4. And f of 5 pi over 4 is e to the 5 pi over 4 times the cosine of 5 pi over 4. Now, first when I look at this, these are some crazy values. I have been teaching calculus for a very long time. I do not know exactly what these values are. I don't just look at this list and say which one's the biggest, but I am going to look at this list and say, is there anything else that I know? Well, I know that e to the 0 is 1, and I know that the cosine of 0 is 1, so f of 0 has to be equal to 1. Okay, maybe that helps. E to the 2 pi, I don't know exactly what that is, but I know e to any power is positive, times the cosine of 2 pi. Cosine of 2 pi is 1, so I've got e to the 2 pi. All right. E to the pi over 4, we've already discussed e to any power is positive. The cosine of pi over 4 is square root of 2 over 2. E to the 5 pi over 4, still positive. Positive what? I don't know. But cosine of 5 pi over 4 is the negative square root of 2 over 2. And maybe you're looking at that and you're like, oh my God, I get it. Maybe you're like, yee, boss, I still don't get this. What are we looking for? We're looking for the absolute minimum value. The smallest value either happens at your endpoints or it happens inside the interval at your candidates. Those are the only places where the smallest value can occur. 1, e to the 2 pi, which is a positive number, e to the pi over 4 times square root of 2 over 2 is positive. E to the 5 pi over 4, I don't know what that is, but I know that that's positive times this negative. That is a negative value. So when I'm asked the question of, let me go back and read the question, find the absolute minimum value, absolute min value of f on the interval 0 to 2 pi is e to the 5 pi over 4 times negative square root of 2 over 2. That was a lot, I know. Here's how they awarded points. They awarded 1 point for knowing to set your first derivative equal to 0. Actually showing that. Not even solving it, showing the work. Another point for coming up with the values, your candidates, of pi over 4 and 5 pi over 4. And then another point, and this is a hard point to earn, for your answer with justification. Here's your answer. This table with all the work is the justification. Grand total of 3 points. Tough question for sure. Absolute max, absolute minimum questions are always going to be butt whoopers. So be careful, be prepared, do the best you can. Let's move on to part D. In part D, they introduce us to a new function. All right. Sorry, I need to arrange my paper a little bit here. They introduce us to a new function, g, which is differentiable, and it satisfies the condition that g of pi over 2 equals 0. Okay? The graph of g prime, the derivative of g is shown below. All right, you know me. G prime, let's make it super clear. This is g prime. Find the value of the limit as x approaches pi over 2 of f of x over g of x, or state that the limit doesn't exist. They want me to find the limit as x approaches pi over 2 of f of x over g of x. Now, I would expect most students are going to do something like this. They're going to say, all right, well, the limit as x approaches pi over 2 of f of x over g of x, well, that's the same as f of pi over 2 over g of pi over 2. Well, what's f? They told us earlier that was e to the x times cosine of x. What's g of pi over 2? They told me that that's equal to 0. Okay. Gosh, how does that get me anywhere? Well, e to the pi over 2, I don't know. Cosine of pi over 2 is 0. I get 0 over 0. And you're going to get all excited and you're going to say, oh my gosh, 0 over 0. It's the indeterminate form. I get to use L'Hopital. That's true. You get to use L'Hopital's rule, but this work doesn't count. This doesn't meet the standard that the College Board has set. What you have to do in order to use L'Hopital's rule is show that you have evaluated the limit of the numerator and the denominator separately, and that you've established that both functions are continuous. So, gosh, what do I know? I know that f of x is continuous, and I know that g is differentiable, which means that g is continuous. Okay, that's good. That is an essential condition to use L'Hopital's rule. Continuity has been established. But you have to write it out this way. You have to look at the limit as x approaches pi over 2 of f of x separate from the limit as x approaches pi over 2 of g of x. You just have to. The limit as x approaches pi over 2 of f of x can be found by evaluating f of pi over 2, which we know is 0. Because g is continuous, the limit as x approaches pi over 2 of g of x is the same as g of pi over 2, which is equal to 0. It's the continuity argument connected together with the limits both being equal to 0, but showing that separately. This is what shows me L'Hopital's rule applies. Anything less than this work over here, you don't get to use L'Hopital's rule, and they are not going to give you the full point. Well, let's keep going. So we're going to say, by L'Hopital, the limit as x approaches pi over 2 of f of x over g of x is equal to the limit as x approaches pi over 2 f prime of x over g prime. Not quotient rule. This is L'Hopital's rule. The limit of this quotient is equal to the limit of the quotient of the derivatives because both functions were continuous and that the both limits are going to 0. Well, what do I know? F prime, well, what's f prime? We know we've got limit as x approaches pi over 2. F prime we found earlier was e to the x times cosine of x minus e to the x times sine of x over g prime. If I evaluate this limit as x approaches pi over 2 in the numerator, I get e to the pi over 2. That's a really ugly cosine pi over 2 minus e to the pi over 2. times sine of pi over 2. Now in the denominator, we're going to have to be really careful. What is the limit as x approaches pi over 2 of g prime of x? This is where you need to go back to your graph. Here's the graph of g prime. The limit as x approaches pi over 2 from both the left and the right is 2. So that means my denominator is 2. These are all numerical values. You don't have to simplify any further, but you can if you want to. The cosine of pi over 2 is 0 minus e to the pi over 2. Sine of pi over 2 is 1, all divided by 2. This first part 0. You get negative e to the pi over 2 over 2. That's your limit, and your notation works all the way through. Limit as x approaches pi over 2 of f of x over g of x is equal to, by L'Hopital's rule, limit as x approaches pi over 2 f prime over g prime, which is equal to this, which equals to this, equals that, equals negative e to the pi over 2 over 2. They offered 1 point for establishing the continuity and that both limits are equal to 0. They then awarded 1 point for applying L'Hopital's rule. Now, I'm not sure if that means at this first step or here when you actually found the derivative. That's a little bit of a mystery to me. And then 1 point for the final answer for a grand total of 3 points. For the kid who just went really fast and never bothered to check continuity, never bothered to evaluate the limits separately, that just starts applying L'Hopital's rule, they get a maximum of 1 point for part D because they didn't stop and do L'Hopital's rule the right way. This is a very clear signal from the College Board that they are expecting more, much, much more when it comes to L'Hopital's rule. So look over this part again, make sure this part's clear, practice this, find some more L'Hopital's rule questions in your homework, and you'll be all set. Good luck. I hope this was helpful.